started recording. Okay.
Yep, I see it.
Okay. So quick recap. You guys can see my screen, right?
Yes.
Yes.
Yeah. We covered forecasting. We covered product life cycle planning. Covered snapshots, lags, and their differences. Right. So today, is the last topic of the supply planning, which is a forecast error calculations. One second. Okay, so forecast error calculation, error accuracy, all that, which is a mandatory step in the demand planning process. So usually, so because once you um, yeah, I'm sorry, I lost. So yeah, so you're planning, and then you're planning that this is going to be your forecast, and then a month passes, a week passes, whatever, and then the actuals will show up, like what exactly has happened in the month, how much you actually sold, and then you need to do a cross check of, are we being accurate? Are we over forecasting or under forecasting? Are we having more demands, ending up creating more demand plans, or ending up creating less demand plans? You know the difference, right? But what happens if we over forecast and what happens if we under forecast? Anybody can tell what is over forecasting and under forecasting? Simple language. Nothing really. You guys are there?
Yes, Joshua.
Yeah, over forecasting means that you have forecasted over. Over forecasting. Right? You said the demand is going to be 100, but the actual sales is 70. So that means you over forecasted 30. It is what happens. You have produced more, and then the stock gets built up, and you incur a lot of costs in producing more. You said that the demand is going to be 100, but the reality is turned out that you actually sold only 70, right? And then this is for 1 week, and usually we do it across a month, standard practice. Then across a month, you see that if you're consistently over forecasting, that means you are piling up the stock, and then um, going to cause a lot of problem, right? So, which means that you over forecasted week one, and after some time, that over forecast of 30 quantity of week one, so that becomes near to wastage, right? Because you need to move the old stock. But if you choose not to move the old stock, and then that becomes an old stock, which might that whole batch might near to the expiry, then everything gets wastage, right? So that's the consequences of over forecasting. You should not over forecast, and then you should not under forecast. Okay, now at least tell what is under forecasting. if my demand is 100, I said demand is going to be 100. And tell me what is under forecasting. Okay, what happened to you guys? So under forecasting means the actual sales
It could be 120 or 150.
happened was like anything greater than 100, like let's say 145. Now in this case,
45.
minus 45,
Minus 40.
which is like, yeah, whatever, 45. That means you are short of 45, but somehow you met 45, right? How you met that 45? By putting strain on the supply chain. What do I mean by strain on supply chain? That means, you might have done extra shifts, right? You might have pushed more those weekends, or you might have sacrificed other customers' demand, or you might have done some subcontracting, that you reached out to third party and you asked for more, uh, you know so you went out to, those subcontracting scenarios, right? So you reach out to another plant which is not owned by you, but you request them to produce it for you, and then you pay them, and they will make for you, and then they'll give the finished goods to you so that you can sell it to your end customer. Regular. Or you might be using advanced shipment modes to satisfy that. Whatever is how we have fulfilled that demand, we don't know. As I've told, these might be the ways of meeting the demand by stretching the supply chain, by putting more costs, more resources, etc. So these are the two things that can happen. Both of the things are not good. Yeah, maybe for some, the business might say for some products, over forecasting is fine, but not under forecasting, right? Especially if you want to maintain high service level. Right? Let's say, yeah. So let's say like we are making smartphones, right? So let's say to the customer, Walmart is a biggest customer, right? So most of our sales coming from Walmart. We want to give high service level to the Walmart, right? So in that, so whenever Walmart puts a sales order, saying that, hey, give me your 100 phones, and I have to make sure that I supply, the right quantity in the right time to the Walmart. So in that case, if I do over forecasting, that is fine, right? Because I don't want to lose Walmart. I don't want to hurt Walmart. I don't want it to, under deliver to Walmart, because I want to be right with Walmart as a strategic alliance, or whatever it is. So your customer base is coming to the Walmart, whatever business unit that you have. So the business might say that, hey, I'm okay with over forecasting for some customers. I might be okay with under forecasting to some customers. Like let's say there are mom and pop stores, right? So if your mom and pop stores, you know those stores, right? So like, yeah, maybe even websites. Let's say there is Amazon. So in the website Amazon, um, let's say your product is out. Most of the time, your product is out of stock. It's fine. So you're okay with it. So because you're under forecast. So that the business will tell. Like, the point is that once the actuals has happened, you have to see that how am I forecasting? Am I forecasting good? Am I forecasting bad? What is my error? What is my accuracy, etc. So this is my understanding. Most of the companies do this thing inside their demand planning tool, whatever the tool is, be it IBP, JDA, Blue Yonder, whatever. Now, forecast accuracy calculations. So the inputs is actual sales, right? And then your forecast. When we say forecast, So the forecast could be anything. So forecast could be a statistical forecast. This is important, but people usually might not do. And then there is a consensus forecast. What's the difference between these two? Silence. Okay. So the difference between is that statistical forecast is mathematically calculated, correct? Based on whatever algorithm. Consensus forecasting is on statistical forecasting. You make adjustments, you override, you add your insights, and then you evolve that numbers, and then you come up with a final number, adding all the planner insights. Right? We're talking many times. So now, again, in the forecast, this could be your regular forecast, or usually it would be lag-based forecast. Will be considered. This is a usual. Usually, we do the lags, not the this thing. Next is measure. What measures you are doing, and then like for example, when we say error, there are multiple measures available. One second, please. Can you guys hear me?
Yes, sir.
Yeah. So when we say errors, there are multiple ways of calculating errors, right? So, for example, MAPE, MSC, MPE, etc. So usually it is a MAPE. Everybody understands MAPE. Everybody likes MAPE. And then there could be other calculations like bias, accuracy, etc. So these are the measures. So these are the inputs. Based on these inputs, and then you pick up a measure, that what measures you wanted to calculate, right? And then there is another thing like time dimension, like data selection, which is like a time. So usually it depends on project to project. So let's say people will say that they do it on the last month actuals and forecast, or some people say last 3 months actuals and forecast. Like why last 3 months? Because they wanted to cover more on an average, right? So you can't just say that I'll just want to get it last month and then see all this stuff. So these are the major things. So now in the IBP there is a profile called as a manage forecast error calculations. So this is where you create the profiles. As usual, you maintain all the settings.
and then you will schedule these jobs, and then you will schedule calendar day, etc. And then the job will keep on getting running, and then the job will keep on giving you the results month on month. Okay, so yeah, again, the frequency of these calculations is usually every month. Yeah? So typically it is every month. Until unless some companies where they are like very aggressive in their demand plannings. So frequency is every month. Right? That means you will calculate this every month. Okay. Right. So now I'm going to say new, creating new profile, brand new profile. And I'll say that this is forecast survey. Calculations. Learning area is Jant, right? Okay, at what level? The calculation level. Oh boy, that is very important. So, see, at what level you are calculating, is very important. Okay. Hello. You
Yes,
guys are
sir.
there?
Yes.
Yeah, great, thanks. So you see this there are these what do we call in English? Political consultants. So they predict election results, right? By polls. What is it? By polls or by polls only, right?
Exit poll. Exit.
Exit polls. Exit polls. Yeah. Yeah, exit polls. So exit polls, they come and they say, oh, this party is going to, they give multiple forecasts, right? And then they project, they predict that in this particular in this state, of course, the elections are happening in the state and in this district and in this constituency. So this is this party X party is going to win. This constituency Y party is going to win, etc. So when the actual results have come in, and then they say that in one constituency, so they say that this constituency the forecast is X, that X party is going to win, but the Y party has won. That means the error is bad. Error is 100%. So, and then you do all of those errors, right? And then if you calculate the errors at a, and then you see that, that the predictions are completely wrong. But if you do the calculations at a district level, right? Meaning that, okay, this particular district, how many total seats are there? There are like 25 contestants, 25 seats are contested. And out of this 25, and he say that, out of the 25, 20 seats would go for party X, 5 seats would go for party Y. This is the district-wide performance. And he has given, you calculate the accuracy at a district level, then you see a different picture. And again, let's say that calculate the accuracy at a state level. Okay, so now at every level, you see different accuracies, different errors coming in. So ultimately, what is important that at state level, his predictions right or wrong is important. Right? Usually, I'm just making up. Or sometimes the district level, the accuracies are very important because state level, yeah, we all know, everybody know that party X is going to win. There is a clear swing. What we're interested is at the district level, there are these strongholds for party Y, and whether party X can really make an impact in those hot seats like red states. So whether Democrats will win in those red states or not. So something like that. So you understood my point. The point is the calculation level. Right? This is very important. So whenever someone says that, hey, my accuracy is 50%, and you have to say at what level you're saying, Is it at a brand level, or is it at a product ID level? Is it at a customer level? Is it sold to party level, sales org level, distribution channel level, etc.? At everywhere, things would differ. So companies are used to do their calculations at a specific level, and then obviously when they implement IBP, we're going to follow the same. We're going to do the same level at this thing. So now here, in our case, it's going to be a same. Yeah, we're going to be month prod log cust. So we have product, location, customer, but month level, not week, because you don't want to calculate accuracy for every week. Correct. So it's too much. So every week you say that my last week is this. So people might do it, but yeah. So okay, now you need to add multiple groups here. So now you say click on add. So now every group has you need to give something. So now I would say that statistical calculation. Okay, what is a sales history key figure? Actuals quantity. What is a forecast statistical quantity? Snapshot. Okay, use lag. This already ticked in because I have selected a key figure which has a snapshot in it. If you don't select it, then the lag would go off. Okay, what lag you want to select? I want to select lag 1. I wanted to forecast only for lag 1. Guys, this is multiple things. Just please try to take in. So we are kind of slicing and dicing, right? So we are calculation horizon 1 month. Offset 0. So there is no offset. Planning level of output key figures, that is also at month prod log cust lag, right? So now outputs would be at lag level because you're taking your forecast at lag level. So if there are 5 lags, so for every lag there's going to be an output. Okay, now these are all the different measures. Mean absolute percentage, mean percentage, weighted mean absolute percentage, mean square error, total root of mean square error, etc. So these are all the different things. So right, in your project, the way you approach this is that you're going to tell that, hey, these are all the measures, best practices made, or you can pick another 2 and then say that, so these are the different measures, but widely people are using it, and you ask the question of what measure you are using, and they'll say mostly MAP, or they say that MPE, and then you say, yeah, fine, bingo, we have it. So you can just select that in the profile, and then so now I've selected it, and then I would say that this is statistical error. This is a key figure. The key figure is already there, right? Because it's a standard, everything is standard key figures, this thing. But in your case, if you create a custom, if and then yeah, you have to create a custom key figures, right? Bias. Yeah, you are following with me. And then there are some settings like replace nulls by 0, exclude outliers, outlier, all of this. So this is all fine, kind of more statistical related. You'll understand. Okay, this is the calculation statistical. Now let's do it for the consensus also. Let's choose 1 and 3. What's the big deal? So here lag 1 3 selected, here also select lag 1 3. Profile was created. Let's send that profile. When you are searching for templates, always make sure that there's a /IBP/. Okay, that is important because there could be multiple templates created by the fellow users. As usual, every job has different settings. We have to make those settings. Profile. This one, forecast of the characters is created by version, base version. Right, and then that's it. Schedule. You have to do check and schedule, but I'm running it anyway. So, well, the job is running. So So actuals is this, forecast is this, right? And then lag is this, errors is this, data selection is this, the frequency every month. This is job schedule. How frequently you run this profile? Calculations, whatever this forecaster, how frequently you run? Once in a month. Calculation level, this is there before, right? In the previous it is there. Okay, yeah, it looks very odd, but it's done. Okay, now I come back here and I do refresh. Okay, so so first of all, we are in February. We are doing we are checking accuracies. We are doing a performance check on January. Right, we are interested in Jan because Jan is done. So now we are in Feb. Actuals quantity is 2822. We sold 2822. We sold this Galaxy Note 5 from the Delhi warehouse to the customer Amazon. Right? We sold 2882. What is a lag? None, because there are no lags for the actuals, right? So now statistical forecasting. Statistical forecasting told some value and then we took a snapshot. This is lag 1 snapshot. This is 2552, whereas lag 3. Now can you guys make up what is lag 3? Lag 3, 3100, meaning that that 3 months back from Jan, 3 months back, we thought the forecast is going to be 3100, which means that December, November, October. In October, we thought the forecast for now January is going to be 3100. That's why lag 3, right? So if lags are important, we'll go there. Now there is a consensus demand plan quantity, again lag 1. Now, what is this? This guy's problem. So this guy is telling that he consensus demand thought the forecast is going to be 2,100. Statistical told 2,552. Consensus demand thought that it's going to be 2,100. That means planners might have decreased the forecast. That's why, right? So the statistical itself is 2,500. How we ended up with 2,100? Because they might have increased it, decreased it. Whereas from a lag 3 perspective, like 3 months back, this consensus demand quantity, they thought that they were aggressive at the time. They thought that it's going to be 3,855. Okay. Now for these numbers, we will calculate accuracy and errors. For this and these numbers, we'll calculate this. You guys are there with me? Okay. So now let's see, for statistical, you have statistical forecast quantity error percentage, statistical forecast quantity bias percentage. For consensus demand plan quantity, you're going to have what? 1 second, guys. 1 second, guys. Hey guys, you guys are there? I'm
Yes,
really
Josh.
sorry. So, yeah, I'm really
Yes,
sorry.
Josh.
Kids. Yeah, so this looks very yeah, maybe confusing or something, like too much. It's a simple things, but kind of getting complicated with the multiple things. So let's focus one by one. Let's focus on these 9.6% and 25.6%. Okay, first of all, why the numbers are showing up here? Because you are calculating on in February. You are calculating February by looking at the January data, right? So the accuracy is going to be come from On the February bucket itself, right? So yeah, that's the way it is. So in the month of February, this is your error. 9.6 is error. But what is that for? That is for the January month. Okay. So now how 9.6 is possible? It's a simple map, right? Simple map. Most famous actual value minus forecast value divided by the actuals value into 1 by n. I mean n by n meaning that if there are multiple things then this thing. So yeah, just go to Google. There's a map is also there in Excel. There's a standard function called Excel. So yeah, in here January actuals is 34, forecast is 37. So it is 37 minus 34 divided by 34, right? So yeah, the difference divided by the this thing. So just like the map, MSE, right? This means square root error. This is the mean square root error, etc. So you can just go and reach out to Google if you have any want to know more about these error measures. MAP is the mostly widely used error measure. Let's come back. So here, let's do this thing. So first, let's find the difference. What is the difference? So actual quantity is 2882, and then the statistical forecast is 2552. So the difference, what's the difference? It is 270. Now, next step is this is. Come on, why I have to make this complicated? So actuals minus forecast, right? And then absolute of actuals minus forecast. Right. So which is absolute. Absolute meaning that it will take off the differences. Now this is absolute minus this thing divided by the actuals. 270 divided by the 280 is 0.99 this thing. So and then you convert that into percentage. Yeah, simple. Okay. Yeah, 9.57% or 9.6%. Round off. Now let's do it for the consensus. The actuals is 2882, and then your consensus is 2100, 772. So this is difference divided by 2882. Okay, now I need to do the absolute of this thing. Okay, what is the first interpretation that we can do out of it? Yeah, the maths is fine. What is the interpretation here? Clearly that the consensus so the interpretation, see, we should, I mean, the business will do the interpretations, not us, but I'll just write that statistical forecast error is less than consensus demand plan. Okay, which means that the planners had planners adjustments are not accurate, correct? Right, because from 2500 what they have done something and they brought down to 2100, right, based on whatever assumptions that they have made and decreased it. So those adjustments are not accurate, right? So yeah, you guys are following?
Yes, yes.
Yes.
What's the other one that we can say? Like for example, consensus demand plan error is higher in lag 3 than in lag 1. Correct? So what is lag 3 error? 36.6%. And then here it is 25.6%. That means they have done something and they brought down the error for lag 1. So which is not good if you focus on lag 3. Right? So you guys are following or not? I'm getting no clue. It's disturbing my flow. So yeah, so lag 3 we remembered, right? So for example, in some companies where there is a lead time, the lags are very important. And then you have to forecast right early. You have to get the forecast right early. In those crazy examples that we have talked, that when you're doing a prediction on this so-and-so hero's film box office collection prediction, and then when you predict before the film is starting based on statistical, and you take this guy's 7 years career, and then you see how his collections are coming in, his box office performance, whether there is any patterns in it, whether there is any trend that this guy is becoming more successful, he's making more profits these days, he's making more money, is he has a lot of fan following, increase or decrease, or is it consistent, or is there a seasonality, blah blah blah. And then you come up with a forecast, and then you publish those forecasts, but you continuously go and disturb that forecast, and then by the time the film is about to release, before a release, a week release, and then you publish a new forecast that this is going to be the collection. And now, from a producer's perspective, from the stakeholders' perspective, that even though the accuracy is good before the film release, that is not a matter. But what is important is how is your forecast when the film was about to start, because the decisions were made at that time based on your forecast. You said his film is going to collect 500 crores. Because of that, we have invested more, we have done this, we have done that. And then you said that he's going to do more in, let's say, in North India belt. That's why we have bought a North Indian, a Hindi-speaking actor into the film, because we thought this is going to fare well in the North India. This was your prediction, but now you're saying that it's not going to do good in North India. What's the point of bringing the Hindi-speaking actor by paying extra buck and all that stuff? So, right. So, which means that for in this case, you have to get the forecast right way before. So in here, in the lag 3, he has done bad. In the lag 3, the error is 36%. But whereas in the lag 1, the forecast is error is 25%. So yeah, he's getting better in coming to the when the event is happening. Before the event is happening, anybody can, and most of the people can predict accurate, right? So you guys are there.
Yes, yes.
Hello.
Yeah.
Yes, Joshua.
Keep going. Yeah.
Naveen, SK.
Yes, Joshua.
Naveen.
Yeah, can you hear me? Yeah, we are there.
Yes, I
Yeah.
can hear you. I can hear you.
Yeah. Okay, yeah. Yeah, so forecasting for you're forecasting a fund performance in the stock market. If you forecast for next month or next week, that would come very good. But you forecast the fund performance for the month of September. That's a tricky thing. So yeah. Anyway, so yeah, this is where I stopped. So quickly, I made a very good flow diagram for you guys. Take this. This is like a big mantra for you guys. And then, so this is like the high level process. So this is the whole demand planning. You get the actuals quantity, integrate actuals, right? I'm saying actuals. It could be sales, revenue, price, whatever. You do segmentation. It's not a mandatory. That's why I put in orange. You do time series analysis. The arrows are going from the actuals because you do that based on the actuals. You do data cleansing, and then you do statistical forecasting based on the cleansing. That's why arrow is going from cleansing to statistical. And then you do your adjustments right? So this is planner insights, right? So this could be inputs coming from promotions, from sales, from marketing, or from finance, etc. There's going to be some key pair calculation logic where you're going to blend these two, and then you're going to come up with a consensus demand. This is your final demand. Now you take snapshots of your statistical and then consensus. Once you have the snapshots and you have the actuals, there is an arrow going like this and there is an arrow going like this. And you do forecast of the calculations. Okay, now you're done. Now you have the consensus demand. What's next? So now you're going to release that demand to IBP systems, or you release it to the S4. It's up to you. You guys know the plan independent requirement, right? In the S4, you can just release it as a plan independent requirement, PIR, into the S4. That's a demand signal directly to the S4. Or if there are other processes in your IBP project, if there are other modules in the IBP project, you will release them to, as per the client requirement. So whichever you have, you're going to release them to there. Okay. So now we're going to do the supply planning. This is a good slide. So I'm going to send this to. Close, save. Okay. Guys, now we are transitioning to the supply planning. Okay. From the forecast errors, we transition into the supply planning. Now the whole thing, the ball game changes. Can you guys tell what is supply planning? What do we do in supply planning?
So you'll plan for your procurement and production based on the demand.
Perfect. Yes, exactly. So this is what we're going to do. Okay. So we said Amazon, and then we said Walmart. Both are being supplied by Delhi warehouse. How will the supply happens to the Delhi warehouse? Let's say there is a plant. This is, let's say, plant. It's called a Chennai plant. Right. So let me just think. Okay, let's just keep one plant. I mean, I want to keep two plants. Well, let's keep one plant, Chennai. Right, and then in the Chennai, we're going to tell that how this smartphone is made, the components that are needed. And then there are vendors. Is going to here, right? Vendor 1, vendor 2. So all of these are different master databases. So this is a supply chain network that we're going to build first. So now I'm going to open up multiple master datas. Okay, maybe let me write down. So there is a product, there is a location, we're covered already, like, so because these are already maintained as part of a demand plan. Now we're going to talk about the supply planning stuff. So first thing is location product, right? So we're going to maintain the I mean, we're going to maintain the products also because we only maintain finished goods. Now is the time where we're going to maintain the raw materials and everything. Locations also we're going to maintain. Raw material, semi-finished goods, and then finished goods. Locations, vendors, plants, DCs, and warehouse. Customer is fine, right? So partner whom we sell. Customer source, how sourcing happens to the customers. Which location is supplying to the customer? Ask me any doubts if you guys have. Location product. Extending products to the locations. Components to vendors, for example. Right? Components and SFG to plant, etc. Okay, and then we're going to maintain location source. Maybe I should write this down here. Location sources, how sourcing happens to a location. Which location is supplying to which location? Okay. Then there's a production source. How sourcing happens inside a location. That is through production process. Right, and then the production source item. What items are required to make the production? Resources. List of unique resources. Location resource. Extending a resource to a location. Production of resource. What resource will be used in the There's one thing on subnetwork, grouping part of the whole supply chain network. Right. And there are some more master data. UM conversion. We'll come back to that later on. Let's start, creating this. So I'm going to say product location customer is there. So I'll say subnetwork and then location product. Location source, production source header, production source item, resource, location resource, production source resource. There are a few more, but these are mandatory. Without these, you cannot have a supply chain. I mean, you cannot run a simple supply scenario. Okay. Okay, 101 is a Galaxy Note. Not too complicated like demand planning. We'll just stick to one finished good, and then we'll do everything on that. So 10101. So what all components you are needed? 90901. Let's say that description for this. What do you need? You need memory chip, something like that. Simple. We'll keep it simple. What else you need? 8001. I need speakers. Simple. Save. Why it takes this much time? Let's see if it is quick from here. Now come to the location. Okay, now Delhi warehouse is there. Now we say Chennai plant, right? And then vendors, right? So memory chip, Qualcomm. Speakers, maybe JBL. You guys know JBL? So let's go international.
Yeah.
Bose Audio International. Right. It's going to be a premium phone. Right? So now, important stuff. For the vendors, you have to mark the location type as a V. V for vendor, that's all. Others you can keep it blank. What's wrong with it? It's too long? Okay. Why? Oh, 20 character only. Okay. I placed my mouse there, it just says that it's a 20 character. Okay. Boss audio right here. Quick. For vendors, we need to mark location type as V. The system understands that these are outside entities. Outside entities of the network. For vendors, there won't be any stock maintained. Correct? For vendors, there is no production maintained. Right? For vendors, we will get the demand on the components which we have to procure, and the vendor will supply it. How? We don't know. No. I mean, how he supplies it, we don't know. So we just assume that he's a vendor. He's going to give it to us. But if it is not a vendor, you have to maintain. You need to maintain the stocks and the production or the transportation lane, etc., etc. Correct? That's the point. Subnetwork. I'll just say, IN India. This is India network. Okay, so like South America, you can have one network, SA. North America, another network, NA. Or within India, you can have South India, North India. So it's just the way you, like for example, for the global PepsiCo, there could be one network as Pepsi, and then Frito-Lay is another network, and then Tropicana is another network, Gatorade is another network, etc. Okay, now see there are like too many stuff here. So let's take our 9001, 8001. Let's put a filter, guys. So I need Note 5, and then I need speakers, and then I need memory chip. That's all. That's all I'm interested in. Okay, location product is all blank. Fine. What locations we have? First, Delhi warehouse. What materials would be there in Delhi warehouse? Can anybody tell? Delhi warehouse will have finished good. Simple. What about the plant? Chennai? Chennai will have everything in this example. Anybody from Chennai?
No, Joshua.
Okay. So Bose is speakers. Speakers is 8001. Qualcomm sends memory chips. Memory chip is 9001. And then there are a lot of attributes in here. Please focus on subnetwork. This is mandatory. You have to tell that this location product what network it belongs to. The network IN. India. Say. Okay, now this is happening. So all these you don't have to maintain. They all will come from integrations. Okay, so location products will come from Marcy. Okay, subnetwork, yeah, you need to, in the integration, you have to default the network, because in the S4 there's nowhere that you will see these things. Now, location source. Where does this come from? This comes from two places. First is special procurement key, and then purchase info record. Are you guys aware of the special procurement key and then purchase info records? Okay, so Delhi warehouse location product is this thing. What ship from location? From which location? Delhi warehouse will get the Note, Galaxy Note. It's from Chennai plant. Okay, and the location Chennai plant 8001 material. From where the Chennai plant will get that? From Bose. Okay. Now I'll ask two questions. Just please tell me why I didn't maintain Chennai plant and 1001. Why I didn't maintain this combination? Should I maintain this or not? Just
The
take a wild
product and
guess.
location key.
Yeah. Why I don't maintain this record? This record here, the location source.
Because it's not manufacturing, it's just a delay.
Sorry.
It's the manufactured at Chennai plant. Is that what you are saying?
Perfect. We have 10 out of 10. Yeah. So you are not, sourcing it. It's not a transportation lane. There is nobody who's shipping Note 5 to Chennai plant. If there is another plant, it's somewhere in Trichy, and then the Trichy is also producing the Note 5. That is your network. You have two plants. And then, yeah, maybe you'll say that, yeah, Trichy is supplying to Chennai. But in this example, there's nothing. Okay, next thing. So Bose is giving this 8001, right? Why I shouldn't maintain this record? Should I maintain this record or not?
it is coming from vendor.
Mhm.
Mm,
So
So you're not making production of it, but you're just receiving that.
yeah, okay. So I'm saying the location ID is a Bose vendor.
Mhm.
Product ID is the 8001, which is the speakers. And why I don't maintain ship from location ID?
They can ship wherever the optimal shipping they get, right? So,
Yeah.
and the order
Okay.
wherever
Yeah.
we place. So it's not
Okay.
just one plant.
Okay. So maybe you get no offense, you get 2 marks here. So the point is that nobody supplies to the vendor, right? So the vendor only supplies to everybody. So you cannot
Right.
just you cannot have your network. Maybe Bose is getting from a different location, but you don't care that. So that is what I meant here when I was when I was trying to write that who supplies it, we don't care, because when the Bose responsibility is that we have a tie-up. Bose has to send the speakers to us in the required configuration, whatever we ask, 1,000 megawatts, 500 megawatts. From where Bose gets, is it from China, from Vietnam? We don't know, and we don't even want to plan for it. So our planning, our headache stops at Bose. That's all. That's why there is no need for transportation link for that. Right? So there are only two ways.
So we
Either you
don't maintain ship
manufacture,
to location here.
the ship to location is a location ID itself.
Oh, okay.
Column C is a location ID, right?
Okay.
So here there are a lot of stuff. So there is an inbound calendar ID where yeah, we'll come to there. We have to take one by one. Otherwise, we'll just get we can't chew everything at one point, right? So there is a limit. Otherwise, we'll vomit out. The inbound calendar ID where we tell that Chennai plant will receive Bose audio speakers only on a specific calendar days, and there is a calendar, and then you maintain that calendar here. There is a lot sizes in how many lots you cannot just send one speaker to Chennai plant, or you cannot send 7 speakers to Chennai plant, right? If you send, you have to send minimum of 100 in the batches of 100. That's a lot size. That's a lot, right? So you cannot send in a big truck. You cannot just put one speaker and then send it. So we don't even create a purchase order like that. So we do in lots. So all of that is there. There is a lead time. There is a how much time it takes from the Bose Audio International to reach Chennai plant. You're going to put a lead time, days or weeks. Um, yeah, there are a lot of stuff. So we'll just put that first. Let's see simple network, how we solve, how we see the outputs, and how we can understand the this thing, right? So that is very important. Otherwise, it just doesn't make. So now when we see this diagram, right, you need to process, not diagram. When we see this screenshot, you need to process like, hey, what is this 9.6%? What is this? What is that? So you need to process it that, oh, okay, this is the statistical forecasting. There is a level, there is a lag, there is a customer ID. It's coming from here and here, 9.6. So you need to have a basic, and even though you might not crack the whole mathematical formula, but we need to have an understanding of that. So that's what I'm trying to do first, and then we'll walk and then we'll run later on. Location source, now production source header. Now this is where the flip side, that where you either produce or you either you procure it. Is there any other way? Right. So either we make or we either we purchase. So those are two different things. So this is where all the purchasing happens, or sourcing from other location happens. In this master data, we're going to maintain how we're going to produce. So now what we're going to produce is only one production happening. This is this. Right. And then you have to give a source ID, means production version. So it's called, like for example, the Chennai plant, this product itself can be made 5 different ways. Then you're going to maintain 5 different records with 5 different production versions. It's a source ID. Right. So now I'm going to say that this is Chennai plant. So usually it is the location ID underscore product ID underscore production version PV001. Okay, now the important things here. Save. Master data are the key for supply planning. Without master data, the master data defines what is your network and what happens where, etc. So now I am interested in important attributes. One is the output product coefficient. Is anyone in from PM module in our batch? Nobody, right?
No.
PM or PPDS?
Mhm.
Yeah. Okay.
No, Joshua.
Sure. So let's put a ratio for just for production ratio, goods receipt time, frozen horizon. This output product coefficient. Yeah, this is important. This is what I'm searching for. And even in the location source also, let's put that ratio thing. Where is the ratio? Location transport. What is a ratio? Ratio is a quota, right? So which means that, like for example, the Delhi warehouse, the same 101, it is getting from Hyderabad plant. What does this mean? The Delhi warehouse, this 10101, it can source either from Chennai or from Hyderabad, or it can also source from Mumbai. There are 3 different players, or there is a vendor in Amirpet, right? So Amirpet can supply anything. So now Delhi can get from 3 different ways. Now there is a way where you can tell it to system that do it in the quota of 0.5, and then this is 0.49, and then this is 0.01. Summation has to be 100%. Simple. You just maintain the split directly. Right? This is a very minimal basic ratio. For example, in some cases where you don't want to scratch and say that, hey, where should I get it? Where should I pass on the demand to? Should I tell Hyderabad plant to produce, or should I shut down the whole Chennai plant and Hyderabad plant and rely only on Amirpet? It's up to you. Now, in our case, our network is very simple. That's why I'll put 1, which means 100% quota from there. Same also in the production source. Right? So output product coefficient is 1. That means output product means when you process this production version, how many units would come out? 1. Production ratio 1. There is only 1 production version, so 100% on this. Production source type indicator, I would say P, which means internal production. Now item. Right, the source ID is this. I'm going to need 2 components to make this 8001 9001. Memory chip, you need okay, what is 800, whatever, and then I'm going to put 2 3. So I'm going to need 2 units of this, 3 units of this to manufacture this. Okay, there are already some resources. I'm going to maintain some resource. I'm going to say W assembler. That's where the assembly happens. You guys know assembly lines, right?
Yeah.
This one, like where things happen. So this is a resource, allocation resource. You have to extend that resource. Where this is in where. Okay, resources could be anything, not just the production resource. It could be storage resource, transportation resource, everything. but we'll keep it simple. We'll just say that it's a simple production resource. Okay. What is the location? Location is Chennai plant. Right. And then, okay, we'll do capacity supply times is indicated. There is something like capacity supply. That means what is the capacity does this assembler have? So if I put X in the key in the attribute time series indicator, this is all supply specific. Whenever you see time series indicator, that means don't read it from the attribute, read the values from the key figure. What's the difference between reading from attribute and key figure? If it is from attribute, it's a single value, consistent, static. Whereas if you key figure, every week it changes. Every week you can have a different value. Yeah, that's a point. Constraint type, I'll put nothing. I mean, you put F, which means that finite resource, which means that it has only certain capacity, and then it can only meet that. So now almost there. Production source resource. Okay, this is where you marry the resource with the production version. Now the next important attribute is a capacity consumption rate. So now if I put 1, that means 1 unit of the capacity is needed to process this production version. So let's assume that we deal in hours. Maybe I'll just say 0.5. It takes 30 minutes to make one phone. I'm going to do a conversion factor. Just give me a minute. Are you guys there with me?
Yes.
Yeah. I'm getting a template. Okay, this is a template that I have just bought. All right. So first thing, so these multiple tabs. So this is a tab 1. This is a standard template. You can use it or you can do whatever. So the customer demand is for the finished good. And then this is where you see the customers. And DC to customer is that the next level of your supply chain, the downstream from customer to DCs. So here you see again finished good, customer, and the locations which are supplying. Transportation is for this is for FG, SFG, and then RM. Now this is between locations. right? So, like for example, DC to DC, plant to DC, plant to plant, vendor to plant, all that stuff. Now this is the production. So this is inside plant. Components. This is inside a plant and the components. And then this is the capacity. This is resources and the plant. So this is resources along with the product. If you guys did not understand anything, like I mean, if it is absolutely blank, you are not making any sense out of it, just let me know. But I know that there's not going to be 100% transition, knowledge transition now, because this is the first time that you guys are seeing it. You need to get the hang of it, just like the way the demand planning. Right? And then the inventory is, everything like FG, SFG, RM, raw material, etc. And then across locations. So there's something like external receipts. We'll see that later on. That is, this is, the components procured from unknown vendor. What do you mean by unknown vendor? Like for example, you're making phones. You have to put it in a cardboard box and then send it, right? So who's supplying that cardboard? I don't know. I mean, that is fine. I will know it later on. So not now. Something like that. So, but whereas I need speakers, and I need to know from where I'm getting the speakers. I need memory chip. I need to know from where I'm getting the memory chip. So those are important. Cardboard box, I might get it from a local vendor, or from, I might do tie up, or I might even place a simple order from online, and then I get it. So, right. So I'll place an order from online, and then they give me these big cartons of cardboards. So which vendor, I don't know. I might go to Amazon, or I might go to Alibaba, or whatever website. So the point is that I need that component, but I don't know the vendor yet. But I want to plan on that component. I want to know how many cardboards I need. I have a Note 5, Note 6, Note 7. I have smartwatches. I have this, I have that. And I need cardboards for it. So I have a Note 5 black. I have Note 5 blue, white, and then there are all these demands coming in. I'm producing all of these, and everything goes in a square shaped cardboard. Which vendor, I don't know, but give me the total demand. Then that is called as an external receipts. So these are the different facets of your supply chain. Okay. Are you guys there with me till now? Okay, so I'll take silence as a beautiful S. So I'll just go,
Yes.
and then I'll go. Yeah. So let's maintain some key figures. So first, there is a key figure called as a consensus demand. That is the demand, finalized demand coming from the demand planning team. So in our diagram, if you guys remember that the demand from demand planning goes to the supply planning, you have to run a copy operator, but let's just run it. So where is this guy? Come on, we don't have time. So yeah, I'll just go must read a workbook. Guys, just bear with me for another 10 minutes, and then we'll close this. So customer sorts. So I wanted to close it. Close the first session of the supply planning, where we kind of go through on a high level master data, and then you guys get a hang of stuff. Oh, there is only one Amazon. Oh, there is no Walmart. Okay. Oh, what did I do? I just maintained sourcing ratio as 1. So this customer is getting this product from only one location, so 100% sourcing ratio, right? So yeah, I'll take this guy and then this guy, and then I'll just go and punch in some hands quickly. I'm going to put a demand on week 11. Just for, I'll put 10,000. No, I'll put 1000. Save. And then one more thing I have to maintain is a capacity. It's called capacity supply. Okay. Where are our location resources? Just go here. Let's say 100. 100. 100 hours a week. Fine. Let's do that. Need not be in hours. It's the way it's up to us. So we can put in seconds or minutes. Okay. Now that we are done, now I'm going to run the supply planning job. Run S&OP operator. It's called S&OP operator. Now I'll run the heuristic. I hope it is infinite heuristic. And then I'll choose what. It's not showing up because I just created that master data. Oh no, why did I disconnect? Yeah, I mean, because I wanted to add this master data as a favorite so that you guys can refer to these master data. That is fine. We can do that later on also. I'll save this as a local Excel sheet and then I'll share it to you guys. I know I have to share a lot of stuff to you. I didn't share any of that. So that is one item on my plate. I need to do that. Hope you guys are getting the recordings.
Yes, Joshua, we are getting right away once the session ends.
Perfect. Now I've selected IN. I'm solving for a network called India network. Okay, run. Now as this is happening, I'll just go and put a filter and then see the status is running. Now you guys have to follow the outputs. It's going to be tricky. Tricky meaning there's too much to grasp, maybe, or maybe not. It's very simple. Let's see. It's saying no data found. How dare you? Is there a filter or something? Yeah, I see some customer region, this and that. But don't tell me that it got failed. Still, first time, right? This takes some time. Supply planning. I've been working in supply planning from last 7 years. So supply planning is my bread and butter. But I have a flair for demand planning. I once led the whole demand planning thing sitting with the client. So that was a very fulfilling experience. So yeah, demand planning is more about numbers and this and that. Supply planning is more about complications. It is finished. Refresh. Yeah, so just follow with me. It's saying that there is a demand of 1000. I punched in 1000, and then it is saying the total customer receipts is 1000. That you can get 1000, right? So we don't want that result, right? So let's flip that. So it's showing all the resources. Let's go and put our resource. Uh-huh. Okay, that is a threshold that I need to maintain. 1 second, guys. There is an alert threshold. Once I maintain the threshold, then I'll get. I'll see the alert. You guys might already start seeing that. Hey, what is this? There are so many tabs and. Okay, guys, just follow this and then just listen it. Yeah, it is saying the total customer receipts. This is output 1. There are multiple output that comes in. So there are 70 or 60 output that comes in once you run the supply planning engine. There are 30 to 40 different inputs that you can give, and then you will get 60 to 70 outputs in supply planning. Okay, in the demand planning, how many inputs you give? There's only one input, which is sales history. How many outputs you get? Yeah, you get multiple outputs, like there is an ex post, there is MAP error, there is statistical forecasting, etc., etc. But supply planning is heavy. Why heavy? Because you see all these tabs. I mean, supply planning has multiple dimensions. There is a work set, resource dimension, there is a vendor dimension, there is a transportation, there is a production, there is a customer. There are some stocks, there are some inventory targets. It's like a lot. So yeah. Okay, now DC to customer. Again, filters. There are filters in this tab. I just picked up a standard template. Yeah. Filter. Take off these ABC codes. Who's interested in ABC codes? Production. Take this off. Why ABC? Who puts these ABC codes? Okay, DC to customer. Back to DC to customer. Okay, so first we are done with. You guys are there with me?
Yes.
Yeah. Interesting or not? Or too vague?
Interesting, Joshua.
Yeah, sure. So this is the customer. First tab, tab 1. We opened Amazon has a demand of 1,000, and then we also saw that Amazon can get all 1,000. It's not possible, but yeah, let's assume that, let's see the result that it is saying that all 1,000 is. Now what we are interested in, now we are next we come to the next downstream. So now we are in here. So now we are in here. So location to the customer. So which is this? So customer is Amazon. Product is 101. Location is Delhi warehouse. So there is a consensus demand is 1,000. Dependent customer demand is 1,000. So that means the demands coming from the Amazon is 1,000. Like if there is a Walmart here, right? And then this is 101, and the dependent customer demand is going to be if the demand is 2,000 there, and then the Walmart will get 2,000 here. Right? If there is another customer, there is another dependent demand. So the multiple demands would come from multiple customers to this location. But for now, it's all one-to-one. Let's assume that all the demands now has come to the location, and they are dependent demands. They are not original demands. They are not independent. They are dependent. They are dependent on the next link in the supply chain. The Delhi warehouse location has a demand now that is dependent on the customer. Okay. Now let's go to the next facet, transportation. Now the transportation is between for now, I think there are filters. It is talking about these plant to the DC. So now here it says that product ID is 101, location ID is warehouse, ship from location is Chennai plant. And again, the demand is 1,000, which means demands have now come onto the Chennai location. Now go to the production. So now here there is 1,000 on the Chennai plant. System has produced 1,000. So now you see the production version coming in here. Production receives is 1,000. Right? So that means the demand now has come to the plant, and then the demand is 1,000. Right now it's the same number that is going again and again. Yeah, so now go to the components. Now in the components, now you see the product is 101 finished good inside the Chennai plant, right? 8001 is a component. The outbound production demand is 2,000. 9001 is other component. The demand is 3,000. Why 3,000, 2,000? Can anybody tell? Why suddenly the numbers have changed from 1,000 to 2,000 and 3,000?
Because your demand plan changed.
No. Why the demands on the components have over 2,000, 3,000? Because you told in the master data that you need two components, 2 units of 8001 to make one finished good. You need 3 units of 9001 to make one finished good. Okay, you need 4 tires to make one car. So that the product ID tire, component tire, product ID car. If you need 4 tires, if the demand is 1,000 cars, the demand on the components is going to be 1,000 cars into 4 tires. Right? The headlamps component coefficient is 2. That means you need 2 headlamps to make one car. Then if the demand for the car is 1,000, the demand on headlamps is 2,000. That is what is happening here. So the components 8001, 9001, the demands are 2,000 and 3,000. Okay, now go to the capacity. What is the capacity supply? How much is the capacity? 100. How much is being used? 500. Why 500? From where now this new number is coming 500? Can anybody tell? In the production source resource, we have mentioned that this production version, Chennai plant AV001, on this assembly line, it takes 0.5 units of the capacity. So one finished good takes 0.5 units of capacity. If it is hours, then one smartphone, one Note 5 takes 30 minutes. Now the demand is coming for 1,000. How much this is going to be there? Okay, 1,000 into 0.5, 500 hours. Okay. Now what is the utilization? It's 500%. Why? Because the available capacity is 100. But utilization is 500%. That means you are utilizing 500 hours. That's why utilization is coming for 500 hours. And it's red in color. Why? Because it's an alert. Why it's an alert? Because you have breached the threshold of 100 hours. 100%. This is not doable.
Not doable meaning that they, you know, it's not doable meaning in the standard sense. Maybe you need to add extra shift. You need to, do find a way. This is the capacity side. And now capacity by product. Again, we have a very simple network. That's why it's all same, which means that this assembler is producing only one product, which is this, and then the usage is $500. The real benefit of this comes in when there are multiple products getting produced on the same assembly, 1001, 1002, 1003, etc. And then you will see that how different products are occupying this resource, how many are getting produced, and how many that each of the product is consuming. Then there is an inventory of all the products. So what was the demands, what's the stock, etc. So, yeah, so I'll stop here. Any points? Anything, guys?
Oh, Joshua.
Is it okay? Or
Yeah.
Yeah, okay, yeah.
okay, yeah, sure. So I'm going to complicate supply planning step by step. I'm going to add, I'm going to talk about different algorithms from tomorrow, different scenarios in the supply planning, different inputs in the supply planning, etc. This is on this base we're going to build more. We're going to expand our network. We're going to add more constraints into our network. That what if I have a lead time? What if there are lot sizes? How to restrict my production to this capacity, etc., etc. And then we'll continue our next couple of days on supply plan. Okay. Thank you, guys. If there are no